Hey, good morning, and thanks for joining us. My name is Manfred, and I'm Vice President of Eco Vino. We are an energy management company that saves to a very specific target audience, most specifically electrically heated buildings where the tenant controls the heat, but the landlord pays the bill. So we have a very narrow audience. And this is a graphic illustration of the problem that just about any landlord will tell you he faces. Tenants will often use open windows to control their comfort level, and as one might imagine, is literally money out the window. Electricity these days, particularly in Ontario, is exceedingly expensive. We know that human nature is such that when there's a perception of something being free, it tends to get wasted. We have clients with monthly hydro bills in the $100,000 range. So obviously very expensive, but yet they want to retain tenants. So it's a fine balance between screwing down the thermostats and retaining revenue, obviously. So what's our solution? It's a hardware and software solution that we've created. We're an Ottawa-based engineering company. And it is recently patented, and we're going to give you a really quick demo right now. My associate Trevor will come to the table, and very quickly, this is a small box, innocuous box that we hide in an apartment, and Trevor will give you a quick idea of how it works.
Hello. So for purposes of this demo, we've built our hardware and software into this iPad and this electric baseboard heater. We don't change the baseboard heaters in the unit we work in. We stay with your existing thermostats and your existing heating infrastructure. All we do is we install a small box. Now I'm going to explain now what the small box does. So I'm going to simulate here on the iPad, I'm going to simulate outdoor temperature. Right now this is a 500 watt baseboard heater, and we can see I'm making it in this room, I'm making it minus 29 degrees, and we're seeing that this baseboard heater is consuming 489 watts. In a design build of a building at minus 30 in Canada, that's about what the design would be built for. So at minus 30, we give the tenants all the heat they need. They should be very comfortable with that temperature. But what happens when the temperature starts to rise? Well, that problem with that is that the building can give them more heat than they need, and that's wasted energy. So what I'm going to simulate now is raising the temperature to around 0 degrees. So I've raised the temperature to 2 degrees, and what our system will do from its calculations is it will limit the heat available in the units to, from this number, about 46% of the available heat energy. So we know that a well-behaved tenant can have any temperature they want at 46% of the heating, 46% energy. Doesn't matter if they're from a warm country, we're tenant friendly, they can stay at the temperature they need. But we're limiting the ability of this baseboard now and the heating system in the unit to produce only 46% of the power that it could normally produce. And we're seeing right now as a feedback from the unit that it's only consuming 247 watts. So even if the tenant were to pin the thermostat, they should be comfortable, but they're no longer able to waste hundreds or thousands of watts. We're only giving them the ability to use the amount of power they should need. And onward, as we raise the temperature, we will allow the baseboard to produce some amount of heat that will allow them to stay comfortable, but not an excessive amount of heat. It's non-confrontational. They will not notice. Their tenant comfort should not be impacted, but they will not be able to waste excessive energy as they could without the system being installed. So we achieve direct energy savings by simply limiting the amount of energy that tenants have to waste in situations where it's simply not needed. Over to you, Manfred.
Thank you. So up on the screen is a conventional building, of course. Each apartment, as mentioned, is equipped with a very discrete box, and it's wirelessly connected via a mesh network to a server. That server then takes outside temperature based on multiple readings, and as mentioned, limits the power that the baseboards are allowed to have. It's a discrete panel. This is a graphic display of how our panel sits simply between the panel, the baseboard heater, and the thermostat, neither of which are changed by us. We simply get in and out in about 45 minutes with our hardware. Our hardware is, in fact, it's unbranded as one would expect, and we are clearly CSA certified and ESA certified. Of course you can. ESA stands for Electrical Safety Authority in Ontario. Yeah. We're also able to install in buildings which have common area closets, for example. In some cases, rarely though, we see panels in common area hallways. Oops, sorry, I pushed the wrong button. There we go. All right, so our graphics will, for example, give a property manager his entire portfolio of buildings. If there were an alert, for example, one of these buildings might light up. So this is something that the head office might want to have, this view. This would be the view, for instance, in a property manager's office on site. And this will be the energy consumption map of the building. And we can see that, you know, buildings on, we can see that each apartment's use at any given moment. We see that outside temperature is, in this screenshot, of 2 degrees with a throttle factor of about 46%. We have an algorithm that we've created that tells us roughly where a client needs to be comfortable. So we can set them the thresholds higher or lower based on individual comfort needs of individual tenants. So we have a seniors residence, for example, where clearly they require a little more power. We allow that to happen. We can also gauge the amount of power an apartment requires based on it facing north or south, lower or upper within the building. We also have a host of data that we can provide. We can give you energy consumption data, you know, instantaneously on a monthly basis, on an annual basis, and we can make it as granular as each apartment, so we can see the outliers that are using excessive amounts of power. We can send alerts, for example. So our software will allow an alert for if an apartment the thermostat's simply never getting satisfied, we will send an alert to a property manager, which might suggest that a window is open and the thermostat's never turning off. That could be a warning of a pipe freeze, for example. It could be any host of reasons why the thermostat's not getting satisfied, but it might warrant a knock on the door. As mentioned, we can send alerts to whoever's authorized to receive them, and clearly we can send data to anybody who is who has an invested interest in learning about it. So that's it for our presentation. We have a booth. It's 2027 here, of course, at the show. We wanted to keep it short and to the point, and obviously invite any questions that you guys might have. Yes. So the question is, what's the approximate payback? We are seeing consistently a 3-year ROI without the Ontario Save on Energy program contribution. We're partnered with Ontario Hydro in all the jurisdictions we're in, and they are rebating between 30% and 50% of our costs. So we're seeing the ROIs as low as 1.5 years. Any other questions? Yes. So the question is, what if there are separate circuits for each of the baseboard heaters in an apartment?
Our box can handle multiple circuits. We've done 1, 2s, and 3s. 3s are fairly common for very large apartments. And we have the ability to monitor consumption of each circuit. So one box will control an entire apartment, and we have the ability to give the energy usage for each of those circuits in the building. No problem at all. Yes, we can control them independently. We try to do that as well because we don't necessarily want them to have a very hot living room and a cold bedroom, so we control that independently. We also have the ability, if someone's familiar with the term, we can do coordinated duty cycle. In large buildings, we may be concerned about exceeding peak loading for billing purposes. We also have the ability to synchronize all the units in the building so that we can keep your entire building energy usage down low while providing the amount of energy that everyone needs.
How can you get fresh air for recirculation in the apartment? There's nobody's saying you can't open a window and get fresh air. What we're suggesting is you can't leave the window open to have constant fresh air and expect to maintain 27 degrees when it's minus 30 out. That's all we're saying. Okay, so what we're really doing is we're curbing waste. When it's minus 30 out, we're not freezing people out of their apartments. That's not our intent whatsoever. It's non-obtrusive and it's non-confrontational. Our product is unbranded. And so really it is, in many cases, today's a perfect example. It's 8 degrees outside. We had, in Ottawa, we had -8 2 nights ago. So we could probably call up a building and show you that there are baseboard heaters absolutely pinned right now in Ottawa at 8 degrees. So, or any of our other sites for that matter. We go to sites, in September, and would call up a remote building, and in one case was 28 degrees ambient outside temperature, and we had 7 apartments with their baseboard heaters fully pinned. We just turned them all off. The tenants had a couple of cool nights, left the heaters on, forgot about them. Inside temperature of their apartments was 35 degrees. They likely weren't home. We turned the power off. So it's that kind of energy savings. Again, we're not here to be, to help. Landlords have a vested interest in retaining clients, and our goal, of course, is to do that at the same time, saving energy, saving the environment, of course, and retaining tenants. So it's really a win for everybody. Incidentally, our name Ecovena, clearly we're piggybacking off the eco trend, but we're really saying Vena is veins in Latin, and so we're making multi-unit apartment buildings veins energy efficient. So that's the nexus of the name itself. Any questions? Any other questions? So the question was, who does the installation? We do not do the installation. We clearly partner with electrical firms in any jurisdiction. In many cases, the landlords have their preferred electricians. So we do have a crew that we work with that's fully trained. We provide the hardware, we manufacture the hardware, the software. It's mostly done in Canada. Some of the circuit boards are offshored. But we'll partner, depending on where you are, with your preferred electrician, or we'll bring our guys in. It's really a cost thing to however the landlord wants to work. Yeah. The question was, can we monitor the kilowatt hours per apartment? We can. So we can give you exact consumption at any moment in time, monthly, annually. Yes. And that's one of the slides was indicating that we can see individual outliers, so we'll see the wasteful tenants very graphically. So, yeah. Yeah, so this, yes. So your question is our software accurate enough so you can sub-bill them? I would answer that it's a legal question. I would argue no. There are companies here that will do sub-metering for you. They do not, in Ontario, are they allowed to deal with baseboard heating. And heating, when you have a building that is where you provide the heating as part of the lease, you can't extract the electricity for the heating. So we partner with companies like that. So we look after the heating component. They'll sub-meter the rest. The issue with the Landlord-Tenant Act, of course, in that regard, is that it clearly, they're grandfathered. So if it's included, it's included until the tenant changes. Then you can put them on a sub-metering basis. Any other questions? Any other questions? Okay. Well, thank you again for attending, and again, we're in the Energy Pavilion, booth number 2027, so please come by.